Hello everyone. This is a calorimeter. It's basically a styrofoam cup with a lid on it and then a thermometer. We use it to do thermal chemical experiments like the one we're going to do today called heat of solution. Now, the purpose of this lab is to experimentally determine the heat of solution of various compounds. We're going to do 3 of them. When a compound such as anhydrous copper 2 sulfate is dissolved in water, it makes an aqueous solution of copper 2 ions and sulfate ions. Energy is released in the solution, gets warmer. The dissolving of anhydrous copper 2 sulfate is exothermic and the heat of solution is negative. Now, here's the reaction that happens. The copper sulfate dissolves into copper ions and sulfate ions. The heat of solution is a negative number, which means that process is exothermic. So it will give heat to the water that is doing the dissolving, and the water will get warmer. All right, we could put the heat of solution in the reaction like this as one of the products. So the copper sulfate solid will dissolve into 2 things and give off some heat. And the water is going to absorb that heat. Now, what does it mean by anhydrous copper 2 sulfate? Now, copper sulfate, remember, is one of those compounds that likes to be hydrated, and normally copper sulfate would have 5 water molecules attached, making it pentahydrate. If we were to get rid of those water molecules, that is, dehydrate it, then we would have anhydrous copper sulfate. That's copper sulfate without water attached. In this experiment, we're going to determine the heat of solution for 3 different compounds. So we need to know what the normal or theoretical heat of solution is for these compounds. So let's take a look at this reference table. We're going to do copper sulfate, ammonium chloride, and calcium chloride. So looking at this chart of heats of solution, we have copper sulfate anhydrous, that's the one without the water attached. That has a value of negative 67.81. That would be in kilojoules per mole. And then we have ammonium chloride, NH4Cl, that's right here. That has a value of positive 16.2. And then there's calcium chloride, which is negative 81.3. Now, if the heat of a solution is negative, that's going to be exothermic to make it dissolve, and that will make the water get hotter. If the heat of solution is positive, like NH4Cl, then that is endothermic, and that's going to make the water get colder because it's going to take heat out of the water, put it into the dissolved ions. Okay, let's take a look at the procedure. It says mass about 4 grams of anhydrous copper 2 sulfate. Add 100 milliliter water to the calorimeter. Record the initial temperature. Add this copper sulfate to the calorimeter. Record the final temperature, and then repeat for the other 2 compounds. Here we have the 3 compounds we're going to use: copper sulfate, ammonium chloride, and calcium chloride. It says to put about 4 grams into a weighing dish. All right, here we go. Now, we don't have to get exactly 4 grams, but we do want to know how much we have. All right, I'm going to go 5.21. Strike that, make that 5.14 grams of copper sulfate. Next, we're going to put 100 milliliters of water into the calorimeter. All right, then we'll put the lid on. Instead of the old school thermometer, we're going to go with a digital thermometer. It's a little bit easier to read. Okay, the original temp now is 21.4. Let's record some data. The mass was 5.14 grams of copper sulfate. The volume of the water was 100, we'll say 100.0 milliliters, which is going to translate into 100 grams later. The initial temperature of the water is 21.4 degrees Celsius. And then we're ready to put the copper sulfate into the calorimeter. All right, we'll pour the copper sulfate into the calorimeter, return the lid, and we'll let it stir. Now, temperature is increasing. The temperature is increasing, which is what we expect because the theoretical value is a negative number, meaning that this is exothermic and it will add heat to the water. All right, give it a second. Okay, it's been about a minute and the temperature is pretty much stabilized at 22.6 degrees. All right, let's record that. 22.6 degrees Celsius. The change in temperature then is the difference, 1.2 degrees, 1.2 degrees Celsius. All right, that's our delta T. All right, now we're going to repeat that same procedure with the other two compounds. Next, ammonium chloride, about 4 grams. Oh, there we go, 5.07. 5.07. Another 100 milliliters of water into the calorimeter. And then find the initial temperature. Give that a second. 21.9. Now we add the compound to the calorimeter. And we let it mix. Right, let's record some data. Again, we used 100 milliliters of water, and the initial temperature was 21.9 degrees Celsius. All right, about a minute later, the water temperature now is 18.6 degrees. That will give a change of temperature of negative 3.3 degrees Celsius. The water temperature went down. Right, the third one, calcium chloride. .36. Another 100 milliliters of water. Find the initial temperature. Let's go with 22.0. 22.0. 100 milliliters again. Add the compound. Calcium chloride. And we'll let it swirl and sit for a minute. Okay, it's been about a minute. Temperature is stabilized at 25.6. 25.6 degrees. Therefore, our change in temperature is, an increase of 3.6 degrees Celsius. All right, there is our data. In the next video, we'll walk you through the calculations part of the lab.